Okay, so before we start with this exercise on finding the area of shapes, we need to make sure that we're familiar with these formulas. So there's a formula for the area of each of these shapes, and you might like to write these formulas down in your maths book. I think that's probably a very good idea because these formulas will form the basis for all of our work in surface area and a lot of our work in volume as well. So this is our holy Bible for this topic. We need to memorize these formulas and get used to using them without checking a formula sheet. Now, you don't have to draw the diagram if you don't want to, but make sure you know what length you're referring to in your formula. Especially with areas like the area of a rhombus here, you don't want to just copy down this formula and forget that x and y here, well, they're the lengths of the diagonals inside the shape, okay? So you don't want to copy this down and then when you get to a question with a rhombus, start using these side lengths here instead. You need to make sure you know what x and y are if you're copying this formula down. So you might like to draw the diagram to help you with that, or at least write a little note down next to your formula explaining that x and y are the two diagonals. Same thing with the trapezium over here. You want to remember that h is the perpendicular height, not the slant height over here. And you also need to remember that A and B, well, they're the two parallel sides. We don't want to get confused about which sides we're talking about. So make sure you know what all of these pronumerals are: length, breadth here, base, perpendicular height. We need to make sure we know what we're talking about when it comes to these formulas. I think we've come across most of these formulas before in years 7 and 8. We might not have seen the area of a sector before down here, but I think the area of a sector is actually even easier to remember than the perimeter of a sector, which we just did. It's very similar in that the area of a sector is just going to be a fraction of the area of a full circle over here. So it's just that same fraction that we find using the inside angle of the sector here over 360. And then instead of multiplying by the formula for circumference, we multiply by the formula for area, because this time we're finding area, not perimeter. So don't get confused with circumference and area of a circle. Circumference is 2 pi r, but area, as you can see, is pi r squared. Okay, so pause the video and copy all these formulas down into your book, and then we'll start with the examples. Okay, so example 1 is all about conversions. So this time we're converting units of area. We worked already with conversions of length and a couple of other conversions as well, but we haven't looked at conversions of area yet. Now, if we think about length, this is a length here. Length is a measurement in one dimension. And an example of a unit of length is centimeters. Now, if I wanted to turn this into a measurement of area or a measurement in 2 dimensions, I just need to add another dimension here. So it's going to be centimeters times centimeters now. And you can see that this creates a square. So area talks about the area inside this square. And the unit for area, it's going to be centimeters times centimeters here. So our unit for area is square centimeters. So when we're talking about area, we're talking about squares. And we're going to have to use squares in our conversions as well. So if we come over here to the first example, we need to convert 859 square millimeters to square centimeters. So we're going from square millimeters to square centimeters here. Now, what direction are we going in? Are we going from a smaller unit to a larger unit, or a larger unit to a smaller unit? We're going to a larger unit. So because we're going to a larger unit, we're going to be able to fit less of this larger unit in our given area, in our given space. So we need a smaller number and we're dividing. Whenever we go from a smaller unit to a larger unit, we need to divide. Now, what are we dividing by? Well, we can still ask ourselves how many millimeters in a centimeter. Really what we want to know is how many square millimeters in a square centimeter. But if we go back to length, that's going to help us out because remember that area is just length squared. So how many millimeters are there in a centimeter? 10. So we divide by 10 squared. If we were converting from millimeters to centimeters, we would divide by 10. But because we're converting from square millimeters to square centimeters, we divide by 10 squared. And it's that simple. So 859 divided by 10 squared, 859 divided by 10 squared is 8.59. So if we're converting this to square centimeters, it's going to be 8.59 square centimeters. And now if we do this example, we're going from square meters to square centimeters. So we're actually moving from a larger unit to a smaller unit this time, which means we need to multiply because we're going to be able to fit a lot more of this smaller unit in the space than we are the larger unit. So our number's going to get bigger. We're moving to a smaller unit, we multiply, and we're going from meters to centimeters, or square meters, sorry, to square centimeters. So how many meters are there? Sorry, how many centimeters are there in a meter? 100. So because we're going from square meters to square centimeters, we multiply by 100 squared because area is length squared. So our conversion is going to be the same conversion as we use for length, but squared. So 2.37 times 100 squared is 23,700. So 2.37 square meters is the same as 23,700 square centimeters. Okay, now for example 2, we need to use our formulas for area. It says find the area of each of the following plane figures. So we just need to make sure we can identify the shape and then use the correct formula for the shape. So in this case, I can see I've got 2 parallel sides here and 2 parallel sides here. So that means that this must be a parallelogram. And the formula for a parallelogram, well, for the area of a parallelogram, sorry, is area is equal to the base times the perpendicular height. So if I can remember this formula, all I need to do now is plug in my values. I can see that this is my perpendicular height, 1.5 centimeters, and this length here is my base, 3 centimeters. So my area is 3 times 1.5. Now 3 times 1.5 is 4.5. And we were working with centimeters, lengths that were in centimeters. So our area is going to be square centimeters. And that's pretty easy, pretty straightforward. Let's do another shape. So this shape here, we can identify it as a triangle. We know that the area of a triangle is given by a half times the base times the perpendicular height. So it's going to be a half times our base in this triangle is this 11 kilometer side here. And our height is this perpendicular height. We have to be careful that we don't take the slant height. It has to be perpendicular to the base. So it's this 5 kilometer length here. Now everything was in kilometers, so our answer is going to be in square kilometers. So a half times 11 times 5 is 27.5, and it's in square kilometers. So that's our area of the triangle. Now this shape here, it could be a parallelogram. It is a parallelogram because we can see that the opposite sides in this shape are equal. But it's a special type of parallelogram because I can also see, it's a bit difficult to see because there's a lot going on in this drawing. This line here indicates that all of the sides are also the same length, which means that it's a rhombus. And the formula for the area of a rhombus is given by a half of x times y, where x and y are the two diagonals in the rhombus. So x can be 9 and y can be 10, doesn't matter which way you put it, could be the other way around. So 9 times 10 or 10 times 9, and we end up with an area of, well, 9 times 10 is 90, and divide that by 2 is 45. So our area of our rhombus is 45 square millimeters. We'll do one more example, and this is a sector now. So the area of a sector, it's just going to be the same as the area for a circle, but it's only going to be a fraction of that area because it's only a fraction of a circle that we have here. So what's the fraction going to be? The fraction is given by the angle in the middle here. I mean, the formula is just theta because it could be a different angle for a different sector, over 360 multiplied by the formula for area of a circle, which is pi r squared. And now we just need to plug our values in. Well, our theta, our angle inside the sector is 260 degrees. So we have 260 over 360 as our fraction. And we need to multiply by pi r squared. What's our radius? Our radius is 4 meters. So it's pi times 4 squared. And we can work this all out on a calculator. 260 over 360 times pi times 4 squared, which gives us 36.30, and it was in meters, so our area is going to be in square meters.